I know that most students, when they're trying to determine locations of earthquakes, can find the chart a little difficult to read when you're trying to relate the gap between the P and the S wave to the distance to the epicenter. So I'm going to show you how to read the seismic wave arrival time chart. This one is just completely made up. I'm just showing you how these kind of work. So don't go off of the data here. It's just for demonstration purposes. So you'll see the one in our book has 3 lines, and they look a little different depending on how they're constructed. But they have a blue line, or in my example, a blue line that represents the S wave. So it plots how far the S wave travels as a function of time. So it travels further as you increase the amount of time that's passed since the earthquake started. Same thing with the P wave. The P wave is tracked here. And then let's not worry about the S minus P curve for right now. So just pretend like the blue and the green ones are there. And so what we're saying is, let's say we have a scenario in which in this given earthquake, you have a seismograph that read a 2-minute separation between the P and the S wave. So the P wave hits, then the S wave hits. And so we go over here and we say, okay, what distance vertically on this axis represents 2 minutes? So what you can do is you can take a piece of paper, or in my case, I'm going to take this eraser because it just happens to be the right distance. And I'm going to say that the distance of this eraser represents 2 minutes. So if I go anywhere on here, a 2-minute gap is represented by the height of this eraser. And so now I want to find where there is a 2-minute gap between the P and the S wave. So I can see down here, I would have less than a minute gap vertically, right? But if I run my eraser, my piece of paper you might have along here, and keep it vertical, when I get to right about here where I've placed these 2 dots, that represents a 2-minute time gap. So from here to here, that vertical distance is the same 2 minutes measured here. Okay. So this is my 2-minute gap, and so what I would do is I would go straight down and say, oh, that 2-minute gap relates to a 600-mile distance that those waves had to travel to get that far apart. Now that's the first way that you can read this. Our curve also has an S minus P, or P minus S, it should be wave there. So the difference between those two. And so when we do that, what we would say is, okay, I don't need to worry about this separation. It's already done the subtraction for you. And so I'm going to come across here, and I know I have a 2-minute time gap. So I'm going to come over here. It hits right there, and I would go down, and I would still get 600 miles. So you'll get the same answer no matter what. It just depends on if you want to use the gap between the P and the S wave, or you just want to use the simple curve that has already done the subtraction for you.